Greetings, I'm Deb the developer. In the last lesson, we wrote methods that do something, then stop. This lesson adds the other half, methods that compute something and hand the result back to whoever called them. We'll cover how to declare a return type, how the return keyword works, a shorthand syntax for simple cases, and when to return early. So, in the last lesson, all of our methods were void. They ran code, printed things, maybe updated a variable, and then they were done. Nothing came back out. Here's the problem with that. Imagine you need to know if a student passed a test. You could write a void method that prints passed or failed directly to the console, but what if you don't want to print it right then? What if you want to make a decision based on it, store it somewhere, or pass it to another method? A void method can't do that. Once it prints, the information is gone as far as your program is concerned. Think of it like asking a friend what 7 times 6 is. If they walk to your whiteboard and write 42 on it without saying a word, that's a void method. Useful once, but now it's stuck on the whiteboard. If they just tell you 42 and let you do whatever you want with that answer, that's a return value. The result belongs to you. You decide what to do with it. To make a method return a value, you replace void in the signature with the type you want to return. Int, double, string, bool, whatever that makes sense. Then, inside the method body, you use the return keyword to send the value back. Look at the call on the left side. Int result equals the add. The call add evaluates to the answer. The whole thing is the value. You can store it in a variable, use it directly in another expression, or pass it straight into another method. Return does two things at the same time. It evaluates whatever expression comes after it and exits the method, handing that value back to the caller. After return runs, nothing else in that method executes. One rule worth being clear on. The return type in the signature has to match what you actually return. If your signature says int and you try to return a string, the compiler will not build the project. That type safety catches a whole category of mistakes before your program ever runs. All right, now let's look at a shorthand. A lot of methods are simple enough that their entire body is just one return statement. C# has a compact syntax for those called an expression-bodied method. Instead of curly braces and return, you write the fat arrow, which is equals followed by a greater than, and the expression. These are completely equivalent. The expression-bodied version is just shorter. You'll see it constantly in real C# code, especially for small helper methods. Use it when the body is a single expression. Don't force it onto something that needs multiple steps or an if statement. One pattern you will constantly use is returning a bool, a method answering a yes or no question. Is this score passing? Is this string empty? Does this user have permission? When you name these methods as questions, the code at the call site reads almost like plain English. Is passing? Is empty? Has permission? When a method name is a question, the if statement reads like a sentence. That clarity is worth a lot as programs get longer. One more pattern before we wrap up. Because return exits the method immediately, you can use it to handle problem cases up front and keep the rest of the code flat. This is called early return, or sometimes a guard clause. Here's the motivation. Say this method divides two numbers. If the divisor is 0, we can't do the division. Rather than wrapping the whole thing in an if-else, We check the problem case first, handle it, then return immediately. The happy path never sees the issue. The method checks the edge case, handles it, and returns. The rest of the method doesn't run in that situation. Now, compare that to wrapping everything in an if-else. You get an extra level of indentation, the happy path is buried inside, and every new edge case you add pushes things further in. Early return keeps things flat. Handle the problem first, then write the path that works. You'll see this pattern all over real C# code. Once your methods can produce values and hand them back, you can start composing them. Use the result of one as the input to another. That's where programs with real structure come from. Go write some methods that return something, wire them together, and see what you can build. Don't just watch it, do it.